1, question 27, part B. Express NR in terms of A and B. Now from part A, we have that the journey from S to Q is described as A takeaway B. Okay? Express NR in terms of A and B. They also give you, that S to N, the ratio of the length of S to N to Q is given in the ratio 3 to 2. So if this were 3 long, that's 2 long, so on and so forth, in terms of how they are proportionally. That proportion also affects the vector. So if SQ is A takeaway B, if this journey can be described as A takeaway B, then this 3 and this 2 can have a part to play to tell you what that journey is and what that journey is. You could also use them to find the journeys going back the way as well. Now, it's important to note that any one of those combinations results in a fraction of our original journey, because this whole journey is bigger compared to these pieces of it. So S to N or N to Q, Q to N, N to S. Doesn't matter which one you take, it's a bit of the journey, it's a fraction of the journey. And the fraction specifically you get based on the ratio. This here is 3 long and that there bit is 2 long, let's say. The whole thing is going to be 5 long, so the fractions you're dealing with here are fifths. Now, there is more than one way of doing this, but we'll get back to that. Fifths is the fraction you're dealing with here. So, for example, S to N, I could describe as 3/5 of S to Q. So I can describe it as 3/5, open bracket, A takeaway B. Or if I wanted to go from N to S, it's going to be 3/5 of the opposite journey of that, or in other words, minus 3/5, so N to S, minus 3/5 of SQ. Don't really need that bracket there, excuse me as I write it there, but of course, the fact that you've got 2 values here means you will. N to Q is going to be 2/5 of SQ, because it's going in the same direction of it, whereas if you went from Q to N, it's going to be minus 2/5 of it. Okay, so there's only 2 of those that are relevant to this, but it's just important to mention that, again, like in part A, there's more than one way of doing this. There's more than one way of taking the journey, in this case, from N to R. That's the journey that we care about. So you have 2 choices. You go from here, down and up, or up and along. Whichever one you choose is entirely to yourself. In terms of how I look at it, the first one I see is that I'm going to go along to S, and then I'm going to go along to R. Okay? So N to S I have expressed as minus 3/5 of SQ. So that's going to be the first part of our journey, which will be negative 3/5, open bracket, A minus B. So that takes us from N all the way up to S. Then I need to add the journey that goes from S to R. That's just A, so I can add A to that. What we do then is we break out that bracket. I really made life much easier for myself. You break out that bracket, so you end up with negative 3/5 of A, and you end up with a double negative here giving you plus 3/5 of B. And you then still have that journey of A to add on. Tidying that up, if you have a whole A and you're taking away 3/5, you're left with, too far, you're left with 2/5 of A, and you're adding 3/5 of B. Alright, and in terms of a picture representation of that, this parallelogram, if you really shrunk it, I could almost describe it like you've got the journey here and the journey up there. And that's basically what this thing is. If A is the journey from P all the way along to Q, N to here, whatever point that is, let's call it T, N along to T is a fraction of that. What specific fraction? 2/5 of. So this here could be described as 2/5 of A. And then from T up to R, that is a fraction of this whole journey here, which is B. In this case, it's 3/5 B. So I'm hoping that makes sense. In terms of your answer, it might seem a little abstract, and you can't visualize what it is. Well, in this case, N to T to R is the same as N to R. 2/5 A takes you kind of horizontally, and diagonally you got your 3/5 B.